Okay, now let's talk about something called the slope-intercept form. I've mentioned this a couple of times already, because hopefully this is review for you and you've seen all this already. So the slope-intercept form gives us a way of talking about the slope and the intercept of a line and getting the equation of that line, or going back and forth. So if I wanted, the slope-intercept form of a line looks like this: y equals mx plus b. And if I have the equation written in this way, this is my slope, m, and this is my y-intercept. All right, so when I start talking about a single number as my y-intercept, it does, it does merit some discussion what I mean here. The y-intercept, it has to be on the y-axis somewhere. And we already know when we're talking about a y-intercept, the x-coordinate has to be 0, which means that this, when I say the y-intercept is 0, really what I'm saying is that the y-intercept is the point, or sorry, when I say the y-intercept is b, it means the y-intercept is the point 0, comma b. My x-coordinate has to be 0. My y-coordinate would then be, well, b. Okay, so if I wanted to determine the slope and the y-intercept of this line, what I need to do here is I need to put it into slope-intercept form. This is at least the easiest way. So I'm starting with 3x minus 4y equals 12. To put this into slope-intercept form, you'll notice this is just solved for y. So that's what I'm going to do here. I'm going to solve the equation for y. Let me change this eraser. There we go. So let's see. I'll start off by subtracting 3x from both sides. I get negative 4y equals negative 3x plus 12. Then I'll divide both sides by negative 4. Oops. Now, when I divide both sides by negative 4, rather than dividing this whole thing by negative 4 like that, what I'm going to do is I'm actually going to divide each of these individually by negative 4. It accomplishes the same thing, but this is kind of easier to work with. So we get y, the negative 4 and the negative 4 cancel out. The negative and the negative cancel out. Here we get 3/4 x. I also kind of moved the x off to the side because, again, thinking about your rules for dealing with fractions, those are the same thing. 3/4 x and 3x over 4. Those are the same number. And then we have, well, I guess minus or plus a negative 3. So what I've done here is I've solved for y. Not only did I solve for y, I also kind of broke this other side up so that we have some number times x and then some constant here. This some number times x, this is our slope. And this right here is our y-intercept. It's the point 0, comma, negative 3. So if I was to graph this thing, it's actually pretty easy now. I know it has the point, it must go through the point 0, comma, negative 3. Whenever I'm graphing using the slope-intercept form, you always want to start with your y-intercept. And then I'm going to use my slope to find an additional point. My slope is 3/4, which says I go up 3, 1, 2, 3, and to the right 4, 1, 2, 3, 4, from any point on the line. I only know one point on the line, so that's where I'm starting. So this line would look something like that. When we're talking about horizontal lines, we know the slope is equal to 0. We just saw that before. And if the slope is equal to 0, we go y equals mx plus b. Well, this part's always 0. So a horizontal line would always have the form y equals something. And let's think about how that makes sense. These 2 points, we call this, well, let's call this x1, comma b, and x2, comma b. In order for these points to satisfy the equation of the line, you can see if I plug in the y-coordinate here, I get b equals b. If I plug in the y-coordinate here, I get b equals b. So actually, yeah, both of those points do satisfy this equation. I'm calling it b because, at some point here, it crosses the y-axis at the point 0, comma b, just because that's what the y-intercept is all about. Now that the y-coordinate happens to be every single point on this line. Another way to think about this, the y equals b, this is defining the altitude of every single point. It's saying that every single point has the same altitude, because that's what y is talking. And y's are saying how high you are. Every single point has the same height on this line. So we're saying y is set. And this b is just going to be some number. It's going to be 3 or something like that. Y equals 3. That would be an example. Then conversely, you can kind of then see that vertical lines would have a slightly different form. In this case, this is entirely defined by whatever your x-coordinate is, x comma y1 and x comma y2. Whatever your x-coordinate is here, that's going to be the x-coordinate for every single point. So I think it's generally called a, whatever, it doesn't really matter. The equation of this line would be x equals a. Now, I couldn't really start off with the same way here. I couldn't start off with the slope-intercept form y equals mx plus b because, well, my slope is undefined. And already that causes a problem. I don't know how to plug undefined into an equation. And similarly, my y-intercept is probably undefined as well. So, you might have a y-axis somewhere over here, in which case you don't have a y-intercept, so this would be undefined. Or maybe another alternative is this is the y-axis, in which case you have infinitely many y-intercepts, in which case I don't know what you'd plug in for b in either of those cases. So the whole slope-intercept form just kind of doesn't work when you're talking about vertical lines.